Here's another video from my No Frills playlist. Videos designed to be straight to the point to maximise the number of marks you score in exams. This video is about Newton's third law. You need to know what Newton's third law is. You need to know how to use Newton's third law when objects are in equilibrium, which means either stationary or moving at constant velocity. And there's a challenge to know how to use Newton's third law when objects collide. You might already know about Newton's third law without realising. If you can complete this sentence, that basically is Newton's third law. For every action, there's an equal but opposite reaction. So what is Newton's third law? Well, for 1 mark in an exam, Newton's third law states that whenever two objects interact, they exert equal and opposite forces on each other. Or for a mark in an exam, you can say every action has an equal and opposite reaction. That's the easiest way to explain Newton's third law. It is important to remember that the action and reaction forces act on two different objects at the same time. A lot of people get Newton's third law mixed up with balanced forces. I'll show you about that in a bit. So I've made a nice little video to do with Newton's third law, and here's a checklist that I've came up with. There must be two forces acting on two different objects. The two forces must be equal in size and opposite in direction, and the two forces must be the same type of force. If you need any further explanation about that, watch my video on Newton's third law. There's a link at the top of the screen now. How do I use Newton's third law for objects in equilibrium? The easiest way of thinking about it is tug of war. If this dog and her owner are pulling opposite ends of the rope and they are both as strong as each other, the forces they exert are equal in size but opposite in direction, as shown in the diagram. If we work through Newton's third law checklist to make sure that it actually is Newton's third law that we're looking at here, there must be two forces acting on two different objects. Well, there is. There's a force from the dog on the rope, and there's a force from the rope on the dog. So the rope's got a force acting on it, and the dog's got a force acting on it. The two forces must be equal in size and opposite in direction. Well, they are. From the diagram, you can see the size of the arrows and the direction of the arrows. And the two forces must be the same type of force. Try to notice the subtle difference between action-reaction forces, which are Newton's third law. The forces act on two different objects, the dog and the ground. So there's a force from the dog on the ground, and there's a force from the ground on the dog. So the dog's got a force acting on it, the ground's got a force acting on it, so that's two different objects. Compare Newton's third law to balanced forces, which are not Newton's third law because the two forces only act on one object, in this case, the dog. I'll show you what I mean. You get a force of gravity on the dog and you get a force of the ground on the dog. So the ground is pushing the dog up and the weight is also acting on the dog. Let's look at these forces at the front. You've got a force from the rope on the dog and you've got a force of friction on the dog from the ground. So the friction is acting on the dog and the force from the rope is acting on the dog. So there's only one object involved, the dog. So the reason people confuse action-reaction forces, Newton's third law, with balanced forces is because they both contain two forces that are equal in size and they both contain two forces that act in opposite directions. So the only subtle difference between balanced forces and action-reaction forces is with action-reaction forces, Newton's third law, two objects are involved. Whereas with balanced forces, there's only one object involved. How do I use Newton's third law when objects collide? So remember, Newton's third law is for every action there's an equal but opposite reaction. When object P collides into object Q, object P will exert a force on object Q. Just like that. Object Q will exert an equal sized force on P, but in the opposite direction. Just like that. And you'll get 1 mark for both of those statements. So, we've just covered about 3 marks worth of content, not that much. But how do you get to 100%? Well, 1 mark at a time. So there's never any guarantee that any of this stuff will actually be on your exam in the end of year 11. That's the nature of revision. But because of your resourcefulness and your initiative to work on yourself and your knowledge, you're increasing your success. So well done, work hard and be nice. Bye for now.